Hello friends, so today we are going to discuss theorem number 1.1 Euclid's division lemma. So let's see the general statement of this theorem. Given positive integers a and b, there exist unique integers q and r satisfying a is equal to b into q plus r, wherein r is greater than equal to 0 and less than b. So this is a general equation which you might already know, and a is the dividend, b is the divisor, q is the quotient and r is the remainder. So this is the general statement of Euclid's division lemma, and we are going to see an example and then we are going to generalize it for all numbers. So moving on, Euclid's division algorithm is a technique to compute the highest common factor HCF of two given positive integers. Now you might be wondering what is HCF. So let's see the definition of HCF also. HCF of two positive integers a and b is the largest positive integer d that divides both a and b. For example, the HCF of say 8 and 4 is going to be 2 because it is the largest positive integer that divides both of them. So HCF you might already be familiar with, and we're going to use Euclid's division algorithm to calculate the HCF of two numbers. So let's see that. Example. Suppose we need to find the HCF of the integers 455 and 42. So we need to find the HCF of both these numbers. So let's see how we are going to do that. We start with the larger integer, that is 455. Then we use Euclid's lemma to get 455 is equal to 42 into 10 plus 35. So from the general equation, we have got this. Let's see what we're going to do next. Now consider the divisor 42 as the dividend and the remainder 35 as the divisor, and apply the division lemma again. So you have to apply the lemma again, and here there is a difference. You have to consider divisor 42 as the dividend and remainder 35 as the divisor. So now you'll get a different equation, which is 42 is equal to 35 into 1 plus 7. So now let's see the next step. Now consider the divisor 35 as the dividend and the remainder 7 as the divisor, and apply the division lemma to get this equation. 35 is equal to 7 into 5 plus 0. So we have done the same thing again, and now we have got a remainder of 0. So let's see what we're going to do next. Notice that the remainder has become 0 and we cannot proceed any further, because if you are going to consider 0 as the divisor in the next case, it doesn't make any difference. It's going to be the same for any number. So we are going to stop whenever we get the remainder as 0. We claim that the HCF of 455 and 42 is the divisor at this stage, that is 7. So this was very simple. You just had to reach to the state wherein the remainder becomes 0. And now we can claim that the HCF of 455 and 42 is the divisor at this stage. This stage means when the remainder is 0. So the divisor here is 7. So this is going to be the HCF of these numbers. So I hope that this was a brief intro, and I hope that you got a little hang of how the lemma is used to find the HCF. So now let's generalize this lemma for all positive integers. To obtain the HCF of two positive integers, say c and d with c greater than d, follow the steps below. So I am going to walk you through some steps which are very easy to do, and you can follow these steps every time to find the HCF of any two positive integers. So let's see the steps. Step number 1. Apply Euclid's division lemma to c and d. So we find whole numbers q and r such that c is equal to d into q plus r, where r is greater than equal to 0 and less than t. So we will come across this equation many times, and I hope now you're familiar with this equation. This is nothing but the general equation which you might be familiar with already. So step number 2, if r is equal to 0, d is the HCF of c and d. But if r is not 0, apply the division lemma to d and r again and again and again. Step 3, continue this process till the remainder is 0. So till you get the remainder as 0, you have to keep applying the lemma, change the divisor and the dividend, and continue till you get the remainder 0. The divisor at this stage, that is when the remainder is 0, will be the required HCF. So the divisor, whenever we get the remainder as 0, is going to be the HCF. So keep an eye out for that. You don't want to continue and then whenever you get 0 as a remainder and then also continue. So be very careful while you do this. So here are some bonus tips and tricks for you to understand and do these questions in a very better way and understand these questions in a better way. So let's see. So to check your answer, you can also use prime factorization. From there, you can confirm the HCF which you calculated earlier. So if you're not sure if you have got the right answer, if you've got the right HCF, you can go back to the old method of prime factorization. You can list the prime factors of each number and calculate the HCF from there. This is a very good trick to recheck your answer whenever you're unsure about it. Always use pen and paper to solve such questions. So it's very important that you use pen and paper and don't solve these questions in your mind, because it's going to be very difficult for you and you might make more mistakes and chances of getting a wrong answer also increase. So the last tip which I have here for you, and this is very essential, is that do not skip any steps. Steps are very important and you can also get marks for steps. So it's best to write every step. Don't skip out on any step, because it would help you a lot in figuring out your question. And if you write all the steps, it's very less probable that you're going to get a wrong answer. You're definitely going to get a right answer, so don't skip steps. So I hope that this video helped you in understanding the lemma in a better way possible, and thank you so much for watching.